Good morning, everyone, and welcome to our first official video for fractions for the year. Today our focus is going to be on creating equivalent fractions using multiplication and division. In order to do this, we're not only going to be using written notes, but you will also be seeing me use fraction pieces. Each of you will be getting a copy of the page that I used to create these fraction pieces so that you have the references for yourself as well. All right, so let's get started today. Now, when creating equivalent fractions, you need to understand a couple pieces of vocabulary before you can truly master this. So we need to talk about the word equivalent. Equivalent simply means equal. In our case, the equivalent fractions we're going to be creating today are simply fractions that, while they may be broken up into more pieces or combined to create larger pieces, still equal the same amount. So let's start off with the multiplication side of things, because generally that's going to be a little easier to understand. And so I need my halves and my eighths. So I've got those two sets of fraction pieces. And we're going to be looking at the fraction 1/2. I'm going to move my notes page over here. Oop. 1/2. Now, if I have 1/2, the goal in mind is to create a fraction, a new fraction, with the denominator of 8 that is equivalent to 1/2. So let's write this down. I have 1/2, and eventually my goal is to get a fraction that has a denominator of 8. Now, when I look at this, I say, well, I understand that there's a correlation between 2 and 8. I know that, especially if we're talking about multiplication, that 2 times 4 equals 8. And when you're working with fractions, whatever you do to the bottom, you must do to the top. Or in this case, whatever you do to the denominator, you must do to the numerator. So if I'm multiplying my denominator by 4, I need to multiply my numerator by 4. And if 2 times 4 equals 8, 1 times 4 equals 4. So let's see if we can prove that 4/8 is equivalent to 1/2. So I'm going to get out my 8 pieces. Got them in all sorts of pretty colors this morning. So I have 1/8 there. Here's my 2nd eighth, my 3rd eighth, and my 4th eighth. And using our model, we have now proven that 1/2 is equivalent to 4/8. So if we drew this, if I drew a bar, and I said that this bar equaled 1/2. And I am trying to turn this 1/2 bar into 4/8. So I need to alter this a little bit, because 1/2 is one piece out of 2. So I need to break my original bar into 2 pieces. And I'm going to just very lightly shade that. Now I'm going to have a second bar. And this bar is going to represent our 4/8. eighths. I know that when I'm creating fractions, especially fraction bars, I can split a fraction bar into two pieces by splitting it in half, then splitting those two halves into fourths, and then I can split those fourths into eighths. And now I simply need to color my four pieces. 1, 2, 3, 4. So now you can see that this piece here matches this piece here, and they are equivalent. All right, let's take a look at our next example. I know that I'm writing kind of big, but I want to make sure that everyone can see what I'm doing and really understand how these connections are made. So you might be writing a little bit smaller than I am in your notebook, and that's okay. There's nothing wrong with that. All right, now let's take a look at three-fourths. Now I can use any multiplication to create equivalent fractions. I can multiply 3 times 2 and 4 times 2, which would give us a fraction of 6/8. I can multiply 3/4. I can multiply my numerator and my denominator by 3, and that would equal 9/12. I can multiply 3/4 times 4, which would equal 12/16. All of these would equal the exact same thing. So let's take a look at why. I'm going to draw 3 fraction bars. I'm going to start by splitting my first one into 4 pieces. So I split my first bar in half and then split those halves in half to get quarters. And I need to color 3/4. Now, if I'm multiplying each piece times 2, then that means that I'm splitting each of these pieces in half. So I'm going to use a different color.
Good morning. If you are one of our wonderful GISD workers who are in the building, we've noticed there's some trucks that are parked in some of our employee paid parking spots. So if you could move those, your trucks, that would be so appreciated. Thank you.
Sorry, everybody. Have no control over the PA systems. So now we've taken our 3/4, our 1, 2, 3 pieces shaded out of 4, and we have now split each section 2 more times. So we now have 1, 2, 3, 4, 5, 6, 7, 8 pieces, and 1, 2, 3, 4, 5, 6 of them are shaded. So we've now proven that 3/4 is equal to 6/8. Now let's take a look at 3/4 and 9/12. So once again, I'm going to split my fraction bar in halves and then split them in quarters. I'm going to fill in my 3/4. And now I need to split each section into 3 pieces. So So let's see here. Thirds are a little hard, but you kind of just judge it the best you can. I do not expect your fractions to be perfect. So now we have created a new equivalent fraction. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces shaded out of 10, 11, 12 total. But look at this. It's still equal. They're still equivalent. We've now proven that 3/4 is equivalent to 6/8, which is also equivalent to 9/12. So let's take a look at our last one. Again, we're going to start with our 3/4. Split our bar in halves, then quarters, shade in our 3 pieces, and then we need to split each section into 4 more pieces. So let's see here. There's half and quarters, half and quarters, half and quarters, half and quarters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces out of 12, 13, 14, 15, 16. So we've now proven with beyond a shadow of a doubt that 3/4 is equal to 6/8, which is equal to 9/12, which is equal to 12/16. Now we're going to work these pieces backwards, because not only can you use multiplication to create equivalent fractions, you can use division to reverse the process. So let's get our next section for notes. So the first time we created 6/8, 9/12, pardon me.
We have a GISD van that is parked in our bus lane. If that could be moved pretty quickly, we have buses coming in. So if you could move that, we'd really appreciate it. Thank you.
Apologize for the interruption. And then we also, lastly, had 12/16. Now, in order for you to understand that we can create equivalent fractions by dividing, you first need to make the connection of what common factors these numbers have. I know that I can divide 6 by 2 and by 3. I know that I can divide 8 by 2 and by 4. So that means that my common factor is going to be the 2. Now, yes, I know we can divide both of them by 1, but if we're dividing by 1, we're keeping the fraction the same, and that's not the point. So we're going to divide our numerator and our denominator by 2. And this is going to give us a brand new fraction. 6 divided by 2 is 3. 8 divided by 2 is 4. Wait. That looks familiar. That looks really familiar. Let's take a look at our second one, 9/12. I know that 9 can be divided by 3. I also know that can be divided by 9. So we could even say that 6 could be divided by 6, and 8 or 8 times 1 could be 8. So we could divide those by 6 and by 8 also. And I know that 12 can be divided by 2, by 3, by 4, and by 12. So the one factor they have in common is 3. So I'm going to divide my numerator and my denominator by 3. 9 divided by 3 is 3. 12 divided by 3 is 4. Wait. Once again, I'm seeing something familiar here. Let's take a look at our last one. Maybe we'll come to the same conclusion. I need to list my factors of 12. Well, that would be 2, 3, 4, and 12. And the factors of 16 would be 2 and 4. Well, 2, 4, and 8. Because 2 times 8 is 16, 4 times 4 is 16, and 16 times 1 is 16. But we've already said that dividing by 1 is going to give us the exact same fraction, but that's not what we want. We're wanting to create a fraction that is equivalent but different. So I can see that the greatest common factor is 4. It's the largest number that is a factor that they have in common. So I'm going to divide my numerator and my denominator by 4. 12 divided by 4 is 3. 16 divided by 4 is 4. And if I think about this, I'm seeing a lot of familiarities here. So this is how you can use multiplication and division to create equivalent fractions. Fractions that have the same value, but just are written differently. Thank you so much, everybody. Have a great day, and we'll see you next time.